Hello, welcome back. We are going to discuss how to partition a line segment today, which obviously this means how to divide one. And first we're going to talk about how to find the midpoint. Of course, that's the point that's halfway between 2 points. So if we have these 2 points, 2, 0, and 10, 0, most of you, I hope, already have the answer in your head, because we can surely find a number that's halfway between 2 and 10. We can do this a number of ways. One is we can think of it as the average. What is the average of 2 and 10? And 2 plus 10 is 12, over 2 is 6, so it would make sense that this midpoint here would be at 6, 0. That's one way we can attack this. Another way we could attack this is by thinking about the distance between these 2 points, right? From 2 to 10 is a distance of 8, which means half of that would be a distance of 4, and so if I add 4 to 2, I would get 6. Or of course I could subtract 4 from 10 and get the same value. So this is pretty simple. Let's look at one more very obvious one. Okay, so this time we're moving vertically from the point 01 to the point 07, and this again is very obvious. This is a distance of 6 between here, so I can go up 3 from where I started at 1, or down 3 from 7, or I can think of this as the average of 1 plus 7, or the average of 1 and 7, which of course would be 4, and adding 1 to 4 would be the same thing, or subtracting 3 from 7 would be the same thing, right? So we know that our midpoint here is the point 0, 4. So this is very simple. The question is, what happens if I'm not moving straight up and down or straight horizontally? What if I have 2 points that form a segment like something like this? Okay, so we're going to look at the segment joined by the points 2, 1 and 10, 7. But the idea should be simple here. We just want to combine what we've just done. I know that whatever point I need here should be the x-coordinate of this point should be halfway between the x-coordinates of the 2 endpoints, which is 2 and 10. So it would make sense if the x-coordinate was equal to 2 plus 10 over 2, which is 6. We already found this, right? And it would also make sense that the midpoint of the y-coordinate of the midpoint would be the average of the 2 y-coordinates, 7 plus 1 over 2, which is 4, right? So if x is going to be 6 and y is going to be 4, then it would make a lot of sense if my midpoint here would be 6, 4. So the idea is when I'm finding the midpoint of a segment, all I need to do is find the middle value, or the average value, of the x-coordinates and y-coordinates separately. We can look at a formula for this, which is x1 plus x2 over 2 and y1 plus y2 over 2, right? This is what we would call the midpoint formula. But really, we don't need this, and I don't want us to be thinking about a formula here, because it's much simpler than that. I'm just finding what number is in between 2 values. We can do this very easily. Let's take a look at real quick examples to make sure you got it. Okay, so here are 3 quick examples. If you want to pause it and try them on your own, you can, because I'm going to go through these very quickly. But very simply, we have the midpoint of A and B. I'm going to do the x's first. So x would be negative 3 plus 5 over 2, which is 1. And y is equal to 1 plus negative 5 over 2, which is negative 2. So my point is 1, negative 2. All right. I'm going to do the second one a different way just to show you. Well, I'll do it the same way. 2.1 plus 6.9 over 2, comma, 4.5 plus 0 over 2. That's my point. It's that simple. Okay, and when I add these, I get 9 over 2 is 4.5, oddly enough. And 4.5 over 2 is 2.25. No big deal. Okay, and this third one I am going to do a little bit differently. Let's say I want to do it with the distance thing. So how far is it from negative 4 to 8? That change in x is 22, which means half of that is 11. So if I take negative 14 and add 11, I get negative 3. That should be my x-coordinate, right? The change in y here is 23, which means half of that is 11.5. And if I take 22 and I subtract 11.5, since I'm going in the negative direction to get from 22 to negative 1, I would get 10.5. So this means my point must be negative 3, 10.5. And you can, of course, check that using the formula like we just did. So midpoint's a very simple topic, and I hope we don't have to spend much more time on it. The bigger question is, what if I want to partition a line segment by a ratio that's not 1/2, right? What if I don't want to split it up in a 1-to-1 way like the midpoint does, right? The midpoint splits up a segment into exactly 2 equal parts. This and this is the exact same. What if we want to partition by a different ratio? Okay, so this first example here, we have a segment that needs to be divided into a ratio of 2-to-3. Okay, so I want you to think about this right now. We've got these 2 points, A and B, and it doesn't really matter how accurate my graph is right now. The point is I have this segment, and if I want to split it by a ratio of 2-to-3, then I want to think about how many total parts am I splitting it into. And the idea is I'm really splitting it up into 5 parts, right? 1, 2, 3, 4. I've got 1, 2, 3, 4, 5 equal parts, and I want to find a point where 2 of the parts, I'm 2 parts away from A and 3 parts away from B, right? So I want to attack this in the same general way that we did with the midpoint, but so I want to do it with the differences, right? The difference between 7 and 5 with the x-coordinates is 2, and so I want to go 2/5 of that distance, right? We're saying that this total distance is 2. Whoa, I don't know what just happened right there. Okay, the total distance in the x direction is 2. I want to go 2/5 of the way there. So 2/5 of 2 is 4/5, right? So I'm saying right now I need to travel a distance of 4/5 units from A, right? So that means my x-coordinate is going to be equal to 5 plus 4/5, right, which will give me 5.8. And now I need to do the same thing for my y's. My change in y is equal to 9 minus 3, which is 6. So if I want 2/5 of that distance, 2/5 times 6 is 12 over 5, which if you want you can call that 2.4. So this means that I need to go from 3 towards 9, which means I'm adding. So my y-coordinate is going to be 3 plus this new distance of 2.4, which is 5.4. Okay, so point P should have the coordinates 5.8, 5.4, right? Because instead of going a whole 2 units this way and 6 units that way, I'm only going 2/5 of the way there, right? So I'm only going again 4/5 in this direction and 12/5 or 2.4 in that direction, and that's going to put me at exactly where my point P needs to be. Okay, so let's take a look at another example. This time I have the segment RS, where R is up here and S is down in the 4th quadrant, and I want to divide the segment by a ratio of 1-to-2. And again, the order, I don't think I mentioned this enough, but the order that we write the segment is important. When I say RS, that means I'm starting at R and going towards S. So when we break this up, 1-to-2 means there's 3 total parts, right? When I break this up into its 3 parts, the R going from R is the 1, and then the 2 is after that point. So our new point P is going to be right here somewhere. Obviously my diagram is probably not perfectly accurate, but let's take a look at how to do this. So the first thing I need to do is find the change in x, right? So to get from -4 to 2, I would do 2 minus -4 is a distance of 6. This means I'm traveling 6 units in the positive x direction. And I want to go 1/3 of that distance, right? So 1/3 of 6 is 2 units. So my new x-coordinate is equal to -4 plus 2, which is -2, right? So my x-coordinate here should be -2, which makes sense, right? Because if I go from -4 and I go right 2, I'd be at -2. If I went 2 more, I'd be at 0. If I went 2 more, I'd be at +2. So it makes sense that that's 1/3 of the way. And now I do the same thing for y. My change in y is, again, -2 minus 8. It's -10, right? This makes sense because I'm going down 10 units. Okay, so if I do 1/3 of 10, that's 10 thirds. And so I have my y coordinate should be 8 minus 10 thirds, which would be the same as 24 thirds minus 10 thirds, which is 14 over 3. So my y coordinate is 14 over 3. For you guys that like mixed fractions, this is 4 and 2 thirds. So there's my y coordinate. If you like that, I really prefer mixed numbers, so negative 2, 14, comma 3. Let's take a look at just one last one to make sure we've got this. So again, I've worded it a little bit differently, but the idea is I'm going from A to B. We're going in this direction. Okay, and I want to go 3/4 of that way. Now again, this time I didn't write it as a ratio of 3 to 4. A ratio of 3 parts to 4 parts would mean I have 7 total parts. That's not how this is worded. It's saying 3/4 of the distance, which means how many parts do I have? Exactly 4, and I need to go 3/4 of that way, right? So I would be splitting this up into 4 equal parts, and so we can kind of estimate that our point would be somewhere in this vicinity. So I need to find change in x first. Change in x is 11 minus 3, which is 8. 3/4 of 8 is, of course, 6. So, wow, that's change in y. I can't believe I just did that, but that's the change in y. So I need to, my y coordinate should be by going up 6 from my a coordinate, which was 3 plus 6 is 9. So the y coordinate of my point is going to be 9. Now let's find our x coordinate. The change in x is negative 7 minus 1, which is negative 8. 3/4 of negative 8 is negative 6, meaning I need to go left 6 units, right? So if I start at A, 1 minus 6 gives me negative 5. That's going to be my x coordinate, and so our final location of our point here is negative 5, 9, which makes sense with where we're going, because if I went left 2 more and up 2 more, I'd be exactly at B. So I hope this made some sense. I'm sorry this video is a little bit long, but we'll practice it tomorrow.